Hi everyone, I hope you're well. This is the screencast for the background information on the machine learning project. So in this project, you'll be using Bayes' theorem that we learned about in Lab 12 to write a naive Bayes classifier to predict whether emails are spam, a junk email, or ham, legitimate email. All right, so this first video is just the background information. There will be separate videos for each of the three functions you're writing. And I recommend that to pace yourself, you write and complete one of these functions per class. We're working on this project for the next three classes. So let's take a look at the beginning of the introduction. So that's this document here. Okay, so in this video we'll talk about 1 through 3, and the assignments are each of the three functions. I'll do separate videos for each of those. Okay, so we'll take a look at the program you'll be starting from in a few minutes. Well, there's a function that's called spam.readFiles that does the following. So it goes into the spam and ham folders in your DMC 105 folder and processes a rather large number of spam and ham emails. While processing those emails, it creates a list of the 2,000 word features. So these features are just words. They're the words, the non-noise words. So not words like the, and. But the 2,000 most frequently occurring non-noise words. So these features correspond to the features that you worked with in Lab 12 for the I-100 versus I-500 exercise. Those were main interest, current exercise level, etc. Each email is turned into a document record, right? And the record has two fields, a label, so all the emails that came out of the spam folder are given a label of spam. All the emails that came out of the ham folder are given a label of ham, right? And these are strings. The second field for each email, and its document record version, is a list, a Python list, what we worked with in Lab 11, of all the non-noise words in that email, right? So each email is turned into a document record, and it's these document records that you'll be working with in your functions. Remember, this is a record, so to access label, if you have an email record, and let's say a variable named doc, you would write doc.label or doc.words. Okay. Then the documents are randomly mixed up. The first 10% of them are put into a list named train docs. These are the documents that you'll be computing the probabilities that a naive Bayes classifier needs, the prior probabilities of ham and spam, and then all the conditional probabilities that a feature word appears in a ham email or a spam email. The remaining 90% of the email documents are put into a test docs list, and this test docs list will be used to test the predictive power of your naive Bayes classifier. Then in the end, this function spam.readFiles returns a table record with these fields. Okay, so table.traindocs is a list of training documents, which, remember, each have these fields. Word feats is the list of word features, so the keywords for which you'll be computing the conditional probabilities. So that's be table.wordfeeds. Table.spamCount is the number of spam emails. Table.hamCount is the number of ham emails. So given these two counts, you can compute the prior probability of an email being ham or an email being spam. Or the prior probability of an email being spam is simply spam count divided by the sum of spam count and ham count. Okay, and there are other records in the table, but these are the only ones you'll be using as you write your three functions. Okay, let's look at the program. So we're going to go over to No Machine now. Okay, so you'll be starting from existing code. And be careful. You'll see in your DMC 105 folder two programs, spam.py and spamclassifier.py. Don't open spam.py. That's the Python module that the spam classifier program relies upon. Okay, open spamclassifier.py. Right, and when you open it, if you don't see the line import spam, then you may have opened spam.py. Close it immediately. Don't edit spam.py. This program will run and produce a correct result. Okay, let's do a sample run. And because of all the work it's doing, it takes a few seconds to run. Okay, and when it completes, you see that it is pretty accurate. It correctly classified a bit over 93% of the emails as ham or spam. So what's going on here is that I've written this program in such a way that it can use my versions of the three functions or your versions. What you'll do when you start working on one of the functions is in the line here for that function, change false to true. So let me demonstrate that. Now when you change one of these lines, check the variable explorer and go to the settings, the options, this gear here, and remove all the variables. When you make this transition from false to true, you want to make sure that you're starting from a clean slate. And the reason that I've done this in this way is this allows you to write and test the functions one at a time, and then move on to the next one. Without this, you'd have to write all three functions and then try to test them all simultaneously. And if you ran into errors, you might not know where to start looking in order to correct them. Right, with this, you can work on one function at a time. Run into a problem, you can change true back to false to compare your results against my results. Okay, so now if I run this, okay, so it's saying on line 34, word count is not defined. And that's in conprob because we just switched to using this program's version of conprob rather than my version. And we can see we have this warning that these two variables aren't defined. Okay, so let's define them and then see what happens. Right, so these are two counts. What do we initialize counts to? That's right, 0. Okay, let's try running the program again. Okay, we see that the prediction percentage drops. That's how you'll know if the code you wrote is working or not. You can check this percentage. The percentage will change even with a correctly behaving program. This percentage will change a little bit each time because the emails are randomly mixed up each time. But if you're getting prediction percentage is 90% or above, then your program is behaving correctly. But you may run it one time and see that you have 92%. You may run it the next time and see 94%. That's fine. It should simply be above 90%. Okay. So when you work on your code, you'll be changing false to true here, adding the code for each of these functions. We'll talk about these individually in separate videos. And so we'll be working on these three: con, prob, train, and classified doc. And this is the bottom is the main part of the program. As it says here, don't change any of this code. These warnings are just warnings. This is the magic code that switches between my versions of these functions and your versions of the functions. Here you can see the call to spam.read files that produces the table, and then using that table and the conprob function, train computes all the probabilities. So the prior probability that an email is spam, that it's ham, and then spam dictionary and ham dictionary here are dictionaries of the conditional probabilities that a feature word appears in a spam document and the conditional probability that a particular feature word appears in a ham document. And then the final part of the program tests your classifier against all the test documents. Okay. So talk through that. You're writing these three functions. And then here's some more information on switching between my version of the functions and your version of the functions. Okay, so there's that information appears here, and I think it's also in a comment here. And remember, when you change one of these, bring up the Variable Explorer tab here, and make sure that you remove all the variables. If you don't do this, you may get incorrect results when you run your code. Okay, this completes the overview of what's going on in the background. Check the other three videos for introductions to each of the three functions. All right, you all take care. Bye.